Have you ever just stared at a problem that felt, well, completely impossible? Today, we're going to tackle one of those, and in the process, we're going to learn a really powerful way of thinking from one of the world's greatest living mathematicians, Terence Tao. So get ready to think like a detective, not a calculator.
Okay, so here's our puzzle. Can you take the digits of a power of 2, say 1024, which is 2 to the 10th, and just rearrange them to form another power of 2? Seems simple enough, right? But hold on, what about 2 to the power of 1000? That number has over 300 digits. Trying to check every single rearrangement? That would literally take longer than the age of the universe. There has to be a more elegant way to solve this.
And this is where our journey really begins. We're not just hunting for a yes or no answer. We're learning to see the problem itself in a whole new light.
This is the core idea from Terence Tao. He says math problems are basically a game of hide and seek. The solution is like a hidden gold nugget. Now, the brute force approach, that's like trying to dig up the entire park. But the elegant approach, that's about finding the clever clue that tells you exactly where to dig.
So, let's do that. Let's put away our mental bulldozers and pick up our magnifying glasses instead. It's time to stop thinking about brute force and start thinking like a true detective.
You know, what Tao is really talking about here is this idea of elegance. An elegant solution doesn't just get the job done. Think of it like this. It's the difference between a perfectly folded paper airplane and a crumpled up ball of paper. Sure, both might hit the wall, but one does it with style and actually reveals something beautiful about the laws of flight. Okay, so how do we find these elegant paths? It's not magic, you know. There's a blueprint, a kind of strategic framework that the best problem solvers use.
Think of this less like a rigid recipe and more like a toolkit. It all starts with really truly understanding the problem. Then you might try to simplify it, maybe use smaller numbers to see if a pattern emerges. You use what you already know. But honestly, the most important step here might be the last one. Avoid blind calculation. Don't just start crunching numbers for the sake of it. Every single step you take should have a clear purpose.
This slide just lays it all out, doesn't it? It perfectly captures the two mindsets. On one side, you've got the bulldozer, trying to list out every single power of 2 and check all its rearrangements. It's a messy, endless, and frankly, impossible task. But on the other side, you have the detective, who asks a simple question. Is there a hidden clue, some fundamental property of these numbers that we can use to crack this case wide open?
And that brings us to maybe the most powerful tool in the detective's entire kit, the art of simplification. This is where we find the secret weapon that's going to solve our puzzle in one clean, beautiful move.
It's a concept called modular arithmetic. I know, it sounds super fancy, but you actually use it all the time. Just think of a clock. The hours wrap around after they hit 12, right? If it's 10 o'clock and you add 4 hours, it's not 14 o'clock, it's 2 o'clock. You're just looking at the remainder. That's it. That's all modular arithmetic is.
Now, don't get bogged down in the specific numbers on this chart. The real point here, the big takeaway, is what happens when you apply this wrapping around idea to complex-looking stuff, like powers of numbers. You often uncover these incredibly simple repeating patterns. What looks like total chaos is actually a predictable loop. This is the power of simplification.
So, we've got our tool. We're going to stop looking at the giant, messy numbers themselves. Instead, we're going to use a clever trick related to this whole wrapping around idea to find a hidden pattern.
All right, here's the first key clue, and it's this really cool property of numbers. A number and the sum of its digits share the exact same remainder when you divide by 9. For instance, take the number 123. The digits 1, 2, and 3 add up to 6. Now, if you divide 123 by 9, you get 13 with a remainder of, you guessed it, 6. This trick always works. It's our modulus of 9 secret weapon.
Now for the second clue. And, okay, this one sounds super obvious, but it is absolutely crucial. If you rearrange the digits of 123 to get, say, 321, what's the sum of the digits? It's still 6. Shuffling the digits doesn't change their sum. Keep that in mind.
Okay, let's connect the clues. If you look at the powers of 2 and their remainders when you divide them by 9, you find this repeating pattern, 2, 4, 8, 7, 5, 1, and on it goes. But what's missing? The remainder is never 0. This means a power of 2 can never be perfectly divided by 9. And because of our first clue, What does that also mean? It means the sum of its digits can never be divisible by 9 either.
And there it is, the elegant answer. Let's just put it all together one more time. 1. A power of 2's digit sum is never divisible by 9. 2. Rearranging the digits doesn't change their sum. Therefore, any number you make by rearranging the digits of a power of 2 will also have a digit sum that isn't divisible by 9, which means the new number itself can't be a power of 2. It's impossible. Case closed. No brute force, just a beautiful, clean chain of logic.
So look, the point here isn't just that we solved some tricky math puzzle. It's about how we solved it. We didn't get lost in the weeds of endless calculation. We zoomed out, and we found a way to understand the hidden structure of the problem.
This quote really just sums up the whole philosophy, doesn't it? Great problem solving isn't just about memorizing formulas. It's an art. It's about having the technical tools, sure, like modular arithmetic, but also having the intuition and the creativity to see how a really complex problem can be made simple and beautiful. And that right there is the ultimate takeaway. The most powerful problem solvers don't just find answers. They transform the questions themselves. They take a tangled mess of complexity and, with just a single insight, they reveal the simple, elegant truth hiding at its core.
So I'm going to leave you with this question. Think about a problem you're facing right now. It could be big or small, doesn't matter. Where can you stop the brute force attack? Just step back for a second and start looking for that one elegant insight that changes everything.